Welcome to JavaScript Interview Prep. JavaScript has one of the most misunderstood type systems in all of programming. Today we're going deep. The 7 primitives, objects, the type of operator and its lies, type coercion, both implicit and explicit, double equals versus triple equals, truthy and falsy, boxing, and the type checking patterns that actually work in production. Let's break it all down. JavaScript has exactly 7 primitive types: string, number, big int, Boolean, undefined, null, and symbol. The one that trips people up first is number. JavaScript doesn't have integers. Every number is a 64-bit IEEE 754 floating point. That's why 0.1 plus 0.2 doesn't equal 0.3. It equals 0.3 houses D004. This isn't a JavaScript bug. It's how binary floating point works in every language. Big int was added in ESC 2020 for when you need integers beyond number.max safe integer, which is 2 to the 53 minus 1. Undefined means a variable was declared but never assigned. Null means you intentionally set something to empty. And symbol creates a guaranteed unique identifier. No 2 symbols are ever equal, even if you give them the same description. The type of operator is the standard way to check types, but it lies. Strings, numbers, big ints, booleans, undefined, and symbols all return exactly what you'd expect, but then it breaks. Type of an array returns object, not array. Type of a function returns function, even though functions are objects in JavaScript. And the most famous bug in the language, type of null returns object. This has been wrong since 1995. In the original C implementation of JavaScript, values were stored with a type tag. The type tag for objects was 0. Null was represented as the null pointer, which is also 0. So the type of check saw 0 and said object. It's been 30 years. It will never be fixed because millions of websites depend on this behavior. Changing it would break the web. The fundamental split in JavaScript's type system is primitives versus objects. Primitives are immutable. When you write let s equals hello, then s.to uppercase. You haven't changed hello. You created a new string hello. The original is untouched. You can't mutate a primitive value. Primitives are compared by value. The string hello is equal to another string hello because the bytes are the same. Objects are compared by reference. 2 objects with identical contents are not equal because they're 2 different objects in memory at 2 different addresses. And at the engine level, primitives live on the stack with the variable. Objects live on the heap, and the variable just holds a pointer to the heap location. This distinction affects performance, equality checks, and how arguments pass into functions. Let's see it in code. 2 strings with the same content, triple equals returns true. They're compared by value. When you assign x to y, y gets a copy of the value 10. Changing y to 20 doesn't affect x. They're independent. Now objects, obj1 and obj2 have identical contents. But triple equals returns false because they're 2 different objects in memory, different references. And here's where it gets dangerous. When you assign AR1 to AR2, you're not copying the array. You're copying the reference. Both variables now point to the same array in memory. Push to AR2 and AR1 sees it too. This is the #1 source of mutation bugs in JavaScript. People think they copied an object when they only copied a pointer. Type coercion is where JavaScript gets its reputation. Let's start with explicit coercion, when you deliberately convert types. String conversion is predictable. Everything converts to the string you'd expect. Number conversion is where the traps begin. Empty string becomes 0, not nay-n. That catches people. The string hello becomes nay-n because it's not a number. True is 1, false is 0. Null converts to 0. But undefined converts to nay-n, not 0. Null and undefined look similar but coerce to completely different numbers. Boolean conversion follows a simple rule. There are exactly 6 falsy values: 0, 0, empty string, null, undefined, nay-n, and false. Everything else is truthy, and this is the critical one. Every object is truthy, even an empty object, even an empty array, even new Boolean false. The object wrapper around false is truthy because it's an object. Implicit coercion is when JavaScript converts types behind your back. The plus operator is the main trap. If either side is a string, it concatenates. 1 plus the string 2 gives you the string 12, not 3. But minus, multiply, and divide always coerce to number. The string 6 minus 1 is 5. This asymmetry is why people hate JavaScript coercion. Plus does one thing, minus does another. Comparisons coerce too, but with a catch. If you compare a string to a number with greater than, it coerces the string to a number. The string 10 is greater than 9. But if you compare two strings, it does lexicographic comparison. The string 10 is less than the string 9 because it compares character by character, and the character 1 comes before 9. Then the truly bizarre rules. Null double equals undefined is true. The spec explicitly mandates this, but null does not double equal 0 or empty string. And nan is not equal to anything including itself. Nan triple not equals nan is true. It's the only value in JavaScript where this happens. This is the most asked JavaScript interview question. Triple equals is strict equality, no coercion. If the types don't match, it returns false immediately. Jiachuans. Triple equals the string 1 or 1 is false. Simple, predictable. Double equals is abstract equality. It coerces before comparing. 1 double equals the string. 1 is true because it converts the string to a number first. And this is where the chaos starts. 0 0 double equals empty string is true. 0 double equals false is true. Empty string double equals false is true. But here's the killer. 0 z double equals empty string is true, and 0 double equals the string 0 is true, but empty string double equals the string 0 is false. Double equals is not transitive. If A equals B and B equals C, A does not necessarily equal C. This violates a fundamental law of equality. There's exactly one case where double equals is preferred. Checking for null. Value double equals null. Returns true if value is null, or undefined. It's a clean 2-in-1 check that's shorter than checking both explicitly. Truthy and Falsy. There are exactly 7 falsy values in JavaScript. False, 0, -0, empty string, null, undefined, and nan. -0 is one most people don't know about. It exists because of IEE 744 and it's falsy. Everything else is truthy, and here's where interviewers test you. The string 0 is truthy. It's not an empty string, it has a character. The string false is truthy. An empty array is truthy. An empty object is truthy. And the most mind-bending one, new Boolean false, the object wrapper around the value false is truthy. Because it's an object and all objects are truthy, there's technically a secret 8th falsy value, document all. It returns type of undefined even though it's an object. This exists purely for backward compatibility with ancient IE code that used type of document all to detect the browser. The spec added special behavior just to not break old websites. Here's something that confuses everyone at first. Strings are primitives. Primitives don't have methods. So how can you call to uppercase on a string? The answer is autoboxing. When you access a property or method on a primitive, the engine silently wraps it in a temporary object, a string object, a number object, or a Boolean object. It calls the method on that wrapper, returns the result, and immediately throws the wrapper away. Here's the proof. Assign a custom property to a string. In sloppy mode, it does an error. But reading it back gives undefined. Why? Because each time you access the string, a new temporary wrapper is created. The one you set the property on is long gone. And never use wrapper constructors directly. Type of the string hello returns string. Type of new string hello returns object. They're different types, and the string hello triple equals new string hello is false. The primitive and its wrapper are not the same thing. So how do you actually check types reliably? Typeof works for primitives except null, which we already covered. For numbers, always pair typeof with number.is nan because typeof nan is number. For arrays, use array.isArray. It's the only method that's 100% reliable. Don't use instance of array because it fails across iframes. Each iframe has its own array constructor. Instance of checks the prototype chain, so an array is both an instance of array and an instance of object. For the most robust check, use object prototype.toString.call. It returns a string like bracket object null bracket object array bracket. It works correctly for null, arrays, regex, map, set, everything. It's what libraries use internally. And one more trap. The global isNaN function coerces its argument first. IsNaN of the string hello returns true because it converts hello to nan, then checks. Number.isNaN doesn't coerce. It returns true only if the value is literally nan. Always use number.isNaN. Null versus undefined is a question in every JavaScript interview. Undefined has 5 sources: unassigned variables, missing function parameters, accessing a property that doesn't exist on an object, a function that doesn't explicitly return anything, and the void operator. Null only comes from explicit assignment or specific APIs, like getElementById returning null when the element doesn't exist, or regex_match returning null when there's no match. The key differences beyond typeof. Number of undefined is nan, but number of null is 0. They coerce to different numbers, and here's one that bites people in production. JSON stringify strips undefined values. If you have an object with a key set to undefined, it vanishes from the JSON output, but null is preserved. So if you're sending data to an API and you use undefined instead of null to represent empty values, those fields disappear from the request body entirely. Symbol is the primitive most developers skip. Every symbol is unique. Even 2 symbols with the same description are not equal. The primary use case is hidden object keys. If you create a symbol and use it as a property key, that property won't show up in Object.keys, won't appear in JSON stringify, and won't appear in for-in loops. It's only accessible if you have a reference to the original symbol. This is how libraries add metadata to objects without polluting the public API. The second use case is well-known symbols. These are protocol hooks built into the language. Symbol.iterator makes your class work with for-of loops and spread syntax. Symbol.toPrimitive lets you control how your object coerces to a primitive. These are the extension points of the language. And symbol.for creates shared symbols from a global registry. Unlike regular symbol, symbol for with the same string returns the same symbol every time. This is useful for cross-module communication. Number edge cases are interview gold. Division by 0 doesn't throw, it returns infinity. -1 divided by 0 returns -infinity. 0 divided by 0 returns nan. -0 exists and triple equals +0. That's right, triple equals lies here. Use Object.is to distinguish them. You can prove -0 exists because 1 divided by -0 gives -infinity, not positive. Nan is not equal to itself. It's the only value in JavaScript where x triple equals x is false. Use number.isNan or Object.is to detect it. And integers beyond 2 to the 53-1 lose precision. The numbers 9007199254740992 and 90071925474993 are triple equals true. JavaScript literally can't tell them apart. That's why BigInt exists. If you're working with database IDs, timestamps, or financial calculations beyond safe integer range, you need BigInt. Object.is is the equality operator JavaScript should have had from the start. It fixes the 2 cases where triple equals gives wrong answers. Object.is of nan and nan returns true. It correctly identifies that nan is the same as nan. Object.is of -0 and +0 returns false. It correctly distinguishes them. For every other comparison, it behaves exactly like triple equals. And here's why it matters beyond trivia. Array includes uses. Object.is internally. That's why array.includes nan returns true, while array.indexOf nan returns -1. IndexOf uses triple equals, which says nan doesn't equal nan. Includes uses Object.is, which says it does. Same with map and set. They use Object.is for key comparison. That's JavaScript's type system at the deepest level. 7 primitives, typeof and its lies, explicit and implicit coercion, double equals versus triple equals, Truthy, Falsy, Autoboxing, null versus undefined, symbols, number edge cases, and Object.is. This is JavaScript Interview Prep. Subscribe and hit the bell for more deep dives. See you in the next one.